Welcome to the lesson on container networking. In this lesson, we'll explore how to create and manage networks and how to use bridges to connect containers. We'll also learn how to use container networking to improve deployment efficiency and scalability. This is really powerful because it allows us to create complex networks and services and enables communication between containers and the host system. By the end of this lesson, you'll be able to understand the basics of container networking and its importance. You'll learn how to create and manage networks using Docker and how to use bridges to connect containers. You'll also learn how to use container networking to improve deployment efficiency and scalability. Let's get started and explore these objectives in detail. Let's start with the basics of container networking. Container networking is a critical component of containerization, and it enables communication between containers and the host system. It's based on the concept of networks and bridges, and Docker provides a built-in networking system for containers. This built-in system allows us to create and manage networks and to use bridges to connect containers. Now let's talk about why container networking matters. Container networking improves deployment efficiency and scalability, and it enables communication between containers and the host system. It allows for the creation of complex networks and services, and it's essential for microservices architecture and distributed systems. This is really powerful because it enables us to build complex systems that are scalable and efficient. Let's explore some key concepts in container networking. We have networks, which are a group of containers that can communicate with each other. We have bridges, which are a way to connect containers to a network. We have interfaces, which are a way to connect a container to a network. And we have IP addresses, which are a way to identify a container on a network. These concepts are essential to understanding how container networking works. Now let's talk about Docker networking. Docker provides a built-in networking system for containers, and it's based on the concept of bridges. Docker provides 3 built-in networks: bridge, host, and none. We can create custom networks using the Docker network command. This allows us to have fine-grained control over our container networks. Let's create a network using the Docker network create command. We can specify the network driver and subnet, and we can create a network with a specific IP address range. We can also create a network with a specific name. This allows us to have a custom network that meets our needs. Now let's create a network using the Docker network create command. This command creates a new network with the name MindWork and specifies the bridge network driver and the subnet 1016 . The output of this command is the creation of a new network with the specified name and subnet. Now let's run a container on the MindWork network. This command runs a new container from the Alpine image and specifies the MindWork network to connect to. The it option allows us to interact with the container. The output of this command is the creation of a new container that is running and connected to the MindWork network. Now let's inspect the MindWork network. This command inspects the MindWork network, and the output includes the network configuration and connected containers. This allows us to see the details of the network and the containers that are connected to it. Now let's talk about some common networking scenarios. We have container-to-container communication, where containers on the same network can communicate with each other. We have container-to-host communication, where a container can communicate with the host system. And we have container-to-external network communication, where a container can communicate with external networks. These scenarios are essential to understanding how container networking works in real-world applications. Now, let's talk about some networking best practices. We should use a consistent naming convention for networks and containers, and use a specific subnet for each network. We should use a network driver that meets our needs, and monitor and troubleshoot our networks regularly. These best practices will help us to create and manage our networks effectively. Now let's troubleshoot a networking issue. This command inspects the network, and the output includes the network configuration and connected containers. This allows us to see the details of the network and the containers that are connected to it, and to identify any issues that may be causing problems. Now, let's talk about some advanced networking topics. We can use multiple network drivers to meet our needs, and we can use network plugins to extend the functionality of our networks. We can also use Docker Swarm for networking, which allows us to create and manage complex networks across multiple hosts. These topics are essential to understanding how to create and manage complex networks in real-world applications. Now let's talk about some real-world networking scenarios. We have microservices architecture, where multiple containers communicate with each other to provide a service. We have distributed systems, where containers are distributed across multiple hosts and communicate with each other. And we have cloud-native applications, where containers are used to build scalable and efficient applications. These scenarios are essential to understanding how container networking works in real-world applications. Now, let's talk about some networking security considerations. We should use secure network protocols to protect our data, and we should use network encryption to encrypt our data in transit. We should also use firewalls and access controls to restrict access to our networks and containers. These considerations are essential to understanding how to secure our networks and containers in real-world applications. Now let's talk about some networking monitoring and troubleshooting techniques. We can use Docker logs and metrics to monitor our containers and networks, and we can use network monitoring tools to monitor our network traffic and performance. We can also use troubleshooting techniques to identify and fix issues with our networks and containers. These techniques are essential to understanding how to monitor and troubleshoot our networks and containers in real-world applications. Now let's talk about some common networking mistakes. We should avoid using the wrong network driver, and we should avoid using the wrong subnet. We should also monitor and troubleshoot our networks regularly to avoid issues. These mistakes can cause problems with our networks and containers, and can lead to downtime and lost productivity. Now let's talk about some networking best practices and optimization techniques. We should use a consistent naming convention, and we should use a specific subnet for each network. We should use a network driver that meets our needs, and we should monitor and troubleshoot our networks regularly. These best practices and optimization techniques will help us to create and manage our networks effectively, and will help us to avoid issues and downtime. In summary, we've learned about container networking and its importance, and we've learned about Docker networking and its features. We've also learned about networking best practices and optimization techniques. Next, we'll be exploring more advanced topics in containerization, such as volumes and persistent data. Thanks for joining me on this lesson, and I'll see you in the next one.